So what does the future of technology actually look like? Instead of just guessing, we can get a direct preview by looking at what the leading minds in engineering and science are working on right now. In this explainer, we're going to crack open the blueprint for tomorrow that's being drafted as we speak at Delhi Technological University. So our guide for this deep dive is the Sapientia 2024 report. Now, this isn't just some summary. It's a massive archive of every single research paper published by the university's faculty and students in just 1 year. Think of it like the ultimate high-resolution snapshot of innovation happening in real time. And this really brings up a huge question. We talk a lot about the world of tomorrow, but who is actually building it? Well, the answer isn't in some far-off futuristic lab. As we're about to see, it's happening right now, in the nitty-gritty, detailed research coming out of places just like DTU. To get our heads around this incredible amount of research, we can use this mind map from the report as our guide. It lays out the key pillars of DTU's work perfectly. For our journey today, we're going to focus on 3 of the biggest areas: the absolute explosion of artificial intelligence, the urgent work being done in sustainable systems, and the foundational science that really makes it all possible. First up, the AI revolution. And let's be clear, this isn't just a buzzword anymore, it's a fundamental shift. AI has become this new multi-tool that researchers are using to unlock solutions to problems that, honestly, were once thought to be way too complex or just had too much data to solve. Here's the basic idea. Humanity is practically drowning in data, but we're starving for actual insights. Well, AI and machine learning are the tools that finally let us make sense of all that chaos, to find hidden patterns, make scarily accurate predictions, and build intelligent systems that can learn all on their own. What's so incredible when you see it laid out visually like this is that AI isn't just one single field. It's a catalyst. Just look how it branches out, touching everything from medical disease detection and network security to robotics, human language, and even financial fraud. It's becoming the foundational layer for progress pretty much everywhere. So let's zoom in on a couple of these branches. In healthcare, they're using AI for early disease detection, which could literally save lives. With computer vision, they're giving machines the power to see and understand the world just like we do. In security, they're building defenses that can predict and stop threats before they even happen. And with natural language processing, they're tearing down the walls between how we talk and how computers understand. And this paper title right here, it just shows you how impactful this work really is. This isn't some abstract theory. Researchers are literally pitting different AI models against each other to find the absolute best way to classify brain tumors from medical scans. This is where the code meets the clinic, and it has the potential to completely change patient outcomes. Okay, now let's switch gears and see how these powerful digital tools are being used to help our physical world. The second major pillar of research moves from bits and bytes to the tangible stuff, tackling what is arguably the single greatest challenge of our time: engineering a more sustainable planet. The problem statement is actually really simple, even if the solutions are incredibly complex. We desperately need cleaner energy, smarter ways to handle our waste, and effective ways to stop pollution. At their heart, these are all engineering challenges, just waiting for a solution. And as this map shows, the approach is a full-on, multi-pronged attack. You've got research branching into renewables like solar, creating smarter and more efficient energy grids, which are often powered by AI, and even developing totally new ways to convert our waste directly into usable energy. It's a truly holistic way of looking at the problem. So what does this look like in the real world? Well, it means squeezing more power out of every single sunbeam by optimizing solar panels. It means turning a problem, our trash, into a solution, like biofuels. It means creating the sensor networks that act like our planet's health monitor for air and water. And it even means reinventing one of the world's most common materials, concrete, to make it sustainable. This paper title makes the research feel so immediate, This isn't some abstract model. It's a direct study of a real-world event, a landfill fire in Delhi, and its direct impact on the air that people are breathing. This is science in service of the community, providing the hard data needed to create better policies and protect public health. All right, so we've seen AI transforming our digital world and sustainable engineering trying to save our physical one. For our final section, let's go a layer deeper and look at the foundational science that makes all of these breakthroughs possible in the first place. This is where the innovation gets really, really fundamental. We're talking about creating entirely new materials, atom by atom, with properties we've never even seen before. We're talking about designing the invisible architecture for the 6G networks that will connect our future. It's about building microscopic biosensors that can detect a disease from a single drop of blood, and even re-engineering the very ground that our cities stand on. And sometimes you just come across a paper title that makes you say, wow, this is one of them. Developing a plasma-sprayed ceramic coating to protect hypersonic vehicles. I mean, come on. This is the kind of extreme material science that is pushing the absolute limits of what we think is possible. And here's another amazing example that connects that deep science directly to saving lives. I know the title is a mouthful, but the concept is revolutionary. Imagine an electronic component, smaller than a human cell, that's engineered to be a microscopic detection dog. Its only job is to sniff out the specific chemical markers of breast cancer. This is where material science, electronics, and medicine all come together to create something just incredible. So after flying through hundreds of research papers and dozens of different fields, let's just pull back for a second. What's the big picture takeaway from this incredible year of innovation? Well, you can really see three interconnected themes taking shape. First, AI is the universal accelerator. It's just supercharging progress everywhere else. Second, sustainability has become the central mission. It's driving which problems we choose to solve. And third, the deep breakthroughs in materials and communications are constantly handing us a more powerful toolkit to build the future with. You see, they all work together. And this just leaves us with a final kind of mind-blowing thought. Everything we've just looked at represents the published work from just one university in a single year. That pace of discovery is just dizzying. So the real question is, if this is what 1 year looks like today, what kind of world will all this research build for us in the next decade?